Okay, first of all, thank you for your invitation. What I will present today is a very hot topic, actually, after the Kahramanmaraş earthquake. This topic, response operations and disaster relief operations, became very important. And I have been working on this for about 10 years since I had come to Turkey. And basically, it's intermodal transportation in humanitarian logistics. So my PhD topic was humanitarian logistics. At the time, it was not as, the term was not coined as humanitarian logistics. It was called as emergency supply chain management. But later on, we called it humanitarian logistics, and in Turkish, it's called insani yardım lojistiği. And intermodal transportation is stemming from my work experience. And when I came to Turkey, I wanted to combine these two things. And I finished a career grant for this. And for several years, I have been working on this topic. So first, I will give a brief background of mine. Then I will set the scene. I will present two papers, but the main paper will be this intermodal transportation for the Turkish network, that network flow model. But then I will, before going into that intermodal transportation network, I will set the scene with another paper, which is related with the container warehouse topic. So, as also John mentioned, I have BS, MS, and PhD in industrial engineering. I have been at Çankaya University Industrial Engineering Department for 12 years. I have published 22 papers, advised 11 master's students. Before coming to Çankaya University, I worked in the United States at J.B. Hunt Transport for 2.5 years. And then before that, I was a graduate research assistant for 3 years. And then before that, while I was doing my master's in Middle East Technical University, I was working at Turkey. So what I will present is, as I said, is a career grant, actually. It was funded by TÜBİTAK, and I'm thankful to AFAD and PCD professionals who provided the real-life data, but like any opinions, findings, conclusions, recommendations here in this presentation and in those papers are of mine and my co-authors. And do not necessarily reflect the views of TÜBİTAK, AFAD, PCD, Middle East Technical University, or Çankaya University. So, following this disclaimer, I want to highlight my research team. Like it spent about like 4 or 5 years long research, and Altan, Ayşe, Nur, Şefika, Melike, Hasan, and Simge were all in my research team. They all got their masters. Altan got his PhD from Middle East Technical University Industrial Engineering Department. And so I want to thank especially to my team here as well. They are behind all of this work. So setting the scene, the first thing I want to motivate the topic is like, we are an earthquake-prone country. We are one of the first top 20 countries in the world that is most earthquake-prone. So we have seen a devastating earthquake recently. And this is an aerial view of collapsed buildings in Maraş, Turkey. Like people visiting there tells about like about 70–60% of all the buildings in several cities collapsed. It was a devastating earthquake. But like what we are doing as Turkey to respond to these disasters is we have AFAD. We formed a FEMA-like institution. AFAD was founded after 2010, after like we had Izmit earthquake, and there has been a lot of investments. This is one investment example which we did. These are container warehouses, interior view of one AFAD container warehouses in Turkey. Within Turkey, there were several warehouses, about 25–30 warehouses, and they have containers stacked on top of each other. And within these containers, we have relief materials. And the idea behind this container warehouse is actually shipping without handling the items, relief items within the containers. It would be like, the idea was like just transporting them without handling the tents, blankets, and then shipping them passively using intermodal transportation. So you are seeing here the tents, for example, within the containers. And this is an outside view of a container warehouse with 48 containers capacity. This is an example for 96 containers capacity. And we have here container guest houses as well. So they are directly shipped to the disaster area, and then they can be used for accommodation purposes. And the investment at the time was about $100 million. So it's a lot of investment for a country like Turkey. And they are scattered around Turkey and with these capacities as well. But what I observed, these are the items inside these containers: tents, blankets, bed sheets. What I had seen was like some containers were empty. And what we were seeing is like empty, in order to ship those containers, empty containers must be located at the top layer, since full containers damage the empty ones, increasing the loading time of the full containers to trucks. So the operator must ground the containers to reach the lower layers, like this. Grounding is this. So the idea was just to ship using just shipping and loading onto the trucks, and shipping onto delivering to the disaster locations, but that was another caveat. And there's no maneuvering area within the warehouse. It's a very packed area. And the mobility of containers are performed with cranes. And what I addressed here before setting the scene for intermodal transportation was containers contain different types of relief items in the current layout. So, for example, we have these warehouses in Turkey, and this warehouse had, like, we looked into inventories of these warehouses. Beds and blankets are in this warehouse, tents and beds are in this warehouse, and tents and blankets are in this warehouse. So in order to fully satisfy the beneficiaries' needs, you need both tents, beds, and blankets. Okay, so, and bed sheets, for example. You have to ship and activate all of the warehouses and then send them to the disaster area. But the idea behind this paper was proposing an equivalent warehouse. So having a proper level of inventory that would satisfy one ship, that would satisfy the needs of beneficiaries for all of the needs, okay, for a certain amount of people. So if we convert this to an equivalent warehouse, a certain layout, then I would just activate the Aksaray warehouse, and then it would satisfy the need of the disaster area. So this is the sketch of the solution approach, and this is the proposed layout. And one layer of those container layer. So if you think about this, so this is one layer. So top layer is proposed to compose of these items. Since the dimensions are different, the weights are different number of containers are required to fully satisfy the needs of 1,600 people. And here, entrance and exit is for the trucks coming and going out of the warehouse. So the mathematical model is a variant of the location reallocation problem. I take a total available inventory and distribute that inventory while converting some warehouses to an equivalent warehouse with this layout. So all of the layers in the proposed equivalent warehouse would have these items, and once shipped, it would satisfy the needs of, for example, 48 container warehouse would satisfy about 4,800 people need. Okay, so about 5,000 people would be satisfied with just emptying one container warehouse. So what I will do, I will not go into the details of this, but I will. The objective function was minimizing the total demand weighted distance. So it was allocating the demand disaster areas with the supply points. And we took about a century-old Turkish past earthquake database. We took distances, we took the number, location, capacities, available inventories from AFAD, and then we took some instances and converted those demand instances, past earthquake instances, to a required number of beneficiaries. And then from that, like a tent satisfies 5 people, a family of 5. So a tent satisfies the accommodation need of 5 people, a family. So we converted that from this beneficiary plan. Beneficiary is the disaster victim. And what we had seen was objective function improvement in terms of equivalent warehouses and non-equivalent current layout. Current layout is P equals 0. It's a variant of the P median problem. And when we say P equals 0, we don't allow any equivalent warehouses. We don't convert them, just the current layout is maintained. But when we say P equals 25, we allow all of the container warehouses to be converted. And we are seeing about 14% improvements in the demand-weighted distance. And we determined the warehouses to be converted, which are like Afyon, Ankara, Elazığ, Erzincan, Kocaeli, Manisa, Aksaray, and Kırıkkale warehouses, depending on the usage frequencies, actually, and conversion frequencies. And what we had seen was this number was also coinciding with the p-values. P-value is in the x-axis, and on the y-axis, we have objective function value. So what we had seen was like when we let increasing p-value, which is like we are letting more number of equivalent warehouses to be converted, we are seeing around 8, it becomes steady. So that's why like we picked 8 warehouses and proposed these warehouses to be converted to an equivalent warehouse. And the red circles are in scaled. So that means these warehouses, large warehouses, are used more in this approach. So what our approach was, we were considering taking a historical view. If we had these container warehouses at the beginning of the century, then at the beginning of the 20th century, then these were the warehouses that would be used the most. So it was a retrospective approach. And then among these warehouses, we talked to AFAD, and they said that like these might be too many to convert into equivalent. And then we said that yes, the benefits are visible more when we have high number of beneficiaries, like the one we had in Maraş earthquake. About like 15 million were affected, and 1.5 million were required accommodation afterwards. And what we are seeing is when it is large, the difference between equivalent warehouses is more visible. And after negotiation, we said that, okay, if 8 is too many, then just convert these ones, Aksaray, Afyon, and Kırıkkale warehouses, which are these ones, Afyon, Aksaray, and Kırıkkale warehouses. So the ones in the middle are like must be converted and has to be readily kept available with all inventory. Right now, after Maraş earthquake, we mostly depleted our inventory in all of these. If you want the details of this paper, which is setting the scene for intermodal transportation, you can see in this journal paper the details of the mathematical model and analysis and the motivation behind it. So determination of equivalent warehouses in humanitarian logistics just by reallocation, the available total multiple items of inventories. Then now moving on to intermodal transportation in humanitarian logistics. Again, we applied to Turkish network using retrospective historical data analysis. And this is what we had seen after Maraş earthquake. And it was a devastating earthquake. It was like in 15th century, we haven't seen this. So after like the 5th century, we haven't seen an earthquake this big in the area. So infrastructure is damaged. So once you load the items on the container, you cannot reach to items just by over-the-road transportation. And that was an observation which like we did before because we needed alternative means of transportation just to reach to the disaster area. Having a container warehouse, having the relief items at one place doesn't mean that you can reach to the disaster area. There are a lot of obstacles which we had seen recently in March. So intermodal transportation provides that flexibility. That was the key idea. What is intermodal transportation? It's a type of multimodal transportation that uses intermodal transport units, which are like containers in this case, to avoid handling of goods while changing modes in hubs, load transfer points. Today, intermodal transportation is used heavily in like international transportation, shipment from China, transportation by railroad in the United States. It's in like vast magnitudes of international trade is happening by intermodal transportation. And when an item is shipped and locked in the container, it is directly shipped until it reaches to the factory. So it goes by sea transportation, ocean transportation. It then goes maybe with the rail or over the road transportation. This change of modes, transportation modes, creates this intermodal transportation. So what are the benefits? It's faster without handling the relief items. You don't touch to the relief items. You don't touch to the products. That's why it is used. So you don't open the container door and look what's inside. It's just locked and shipped until the destination. So origin to destination, just a single container is used. Flexibility when over-the-road transportation is not available. So when it is either congested or like damaged like this, we have to use intermodal transportation and offers ample capacity with rail and sea. The capacities of railroad and sea transportation is a lot. So it is suitable and used in humanitarian logistics. Before setting the scene, we looked into the literature and the application. So you can look into this review paper. And it's used, but it's not reported, is what we had seen. And a methodical model that was not available at the time, that's tailored specifically for humanitarian logistics. There are like intermodal transportation models for freight transportation. There were like other mathematical models related to that, but specifically for this we haven't seen at the time. So when intermodal transportation is not used efficiently as it was supposed to be, what we are seeing is like this. So from the depot container warehouse, what you are seeing, the items are handled. This was not the idea behind container warehouses. It takes time to handle these items and load, just go with the forklift. If in the first place it was going to be handled by forklifts and pallets, then why we build these, why we make these investments? So intermodal transportation is required. And this is an example from Erzincan warehouse right after the earthquake. Again, the items are handled by themselves. The problem here is the trucks that can hold the containers are not available in all of these locations. So that's why, like, as a dire necessity, these AFAD personnel had to touch the item because they were not able to find the right trucks just suitable for container transportation. Okay. So, but also we had some good examples in the Maraş earthquake. This was an interesting example that I found. Maybe you might have heard in the news as well. FIFA World Cup Qatar guest houses were shipped using intermodal transportation. So these were the guest houses used in Qatar FIFA World Cup. And Qatar, as a courtesy, sent some of those warehouses to Turkey, and they were implemented in Turkey as like guest houses. And also Erzincan container warehouse, again, a good example for Turkey. Erzincan container warehouses shipped. These are the guest houses, container guest houses, shipped the 290 container guest houses as well. And this is a good example from Muş container warehouse as well. As you see, we don't see containers here. So the containers were able to ship using the proper way, which is like handling the cranes and loading on the containers. So now setting the scene, and this is the problem we are facing. And as a result of disasters, infrastructure is damaged, and we need a way to reach to the disaster area. And we have everything we need, actually. We have the supply points, which we took as locations of AFAD warehouses in Turkey, and transport points between the transportation modes are these locations of Turkish State Railways intermodal hubs. They are called logistik köyler, logistik merkezler. So in Turkish, we have that investment also ongoing. There are some of them are still in construction, some of them are opened, but they are the locations to transfer from rail to road and from road to rail. Okay, so this we have the infrastructure and the ports as well. So we have the ports. For example, the Qatar guest houses arrived to Iskenderun port via sea. Okay, so that's also available for Turkey as well. And this is an example from Eskişehir Logistics Center, where you can see like the maneuvering area, loading area, and transfer between the railroads, and then trucks are loaded, and then they are transferred to the road and trucks here. So taking this supply points, transfer points, that's the hubs, and combined network is like this: container warehouses, logistics centers, and seaports. What we need here is the demand, okay? What we did is followed similar example we used a retrospective analysis. So demand locations are actually the disasters, past disasters that happened in Turkey. So the mathematical model, I will give briefly details about the mathematical model here. The proposed model is a capacitated, dynamic, multicommodity intermodal network flow model, which relief supplies are delivered to beneficiaries via intermodal transportation during a given period, which we focused on 72 hours, the first 3 days urgent period. What does the objective function do? It minimizes the cumulative unmet demand throughout the planning horizon. In large disasters, we cannot meet all demand, but at least we can minimize the unmet demand throughout the planning horizon. We have several assumptions. When we have enough demand, sufficient supply, we satisfy everything. Vehicles run on undamaged operational routes. This means for rail, for example, the road might be damaged, but if the rail is available, use rail. The model allows that. And the origin destination pairs between the cities are also reflected in the availability, just specifically between cities are reflected in the model as well. And another thing that is important for humanitarian logistics is like the resources are scarce. So we have to, for example, over here, why we had only 9 containers shipped from Muş to the disaster area, because it's hard to find empty vehicles immediately. Okay, so having an empty container, empty truck trailer that can hold the container is a scarce resource. It's a problem in that happens. So what we say is containers are sent to a destination node if there are empty vehicles at the origin node, and the empty vehicles are doing cycles between the warehouses and the demand points. And the supply amounts in every depot node are updated in each period. So it's a dynamic model, and it compares, it's a multi-period model. So we have containers, they are the supply nodes, the container depots. We have some locations which have also containers and intermodal hubs. And there are some cities we have just functioning as hubs, intermodal hubs, and the demand location. So this is the arrow directions between the flow directions between nodes. As I said, I will not give much details about the mathematical model, but focus on the results. You can see the details. We have another paper for this one as well. So we have some time duration for intermodal transportation, container inventory, available number of vehicles, depending on the mode, capacity, amount of demand, if the road is accessible or not, That's like what is specific for disaster relief. And decision variables are demand, empty vehicles, loaded vehicles, number of containers, etc. And one thing that I want to highlight is this objective function. S was the unmet demand. And what I'm doing over here is, I haven't seen it in other formulations, I'm penalizing the unsatisfied demand by T. T is the time period. So when time passes, it becomes more expensive to satisfy the demand. So satisfy it earlier, if possible. So when time passes, if this is, let's say, 52nd hour, each T was a time period, then like satisfying the same unsatisfied amount at the 30th hour is favored with this mathematical model. And we have several constraints for mode availability, capacities, vehicle availabilities, if they are transported from nodes. And this is like for shipment with the capacity again. But I won't go into the details of that. So, and demand instances. We had supply, transfer points, and the demand instances. Demand instances, again, used retrospective analysis, earthquake. We added also floods and landslides to this study, so that's more comprehensive. This database includes date, location, number of people who died, were injured, number of collapsed or hard-hit buildings, type and magnitude of the disaster. So when we classified this, we had seen about 305 number of disasters, and majority of them were earthquakes, but like floods and landslides are as well. And we categorized the demands with low, medium, and high. Excuse me, B is the number of beneficiaries, which is like disaster victims that require immediate assistance. And in order to make it more realistic, we talked to AFAD personnel, we talked to Turkish State Railways, TCD'de, and then decided on these capacities and like these average speed of trucks, rail cars, ships, etc. So these are the capacities. Each truck can hold 1 container, rail car can hold 24 containers, and each ship can hold 200 containers at a time. And we gave availability for like 5 trucks immediately available in the hosting container warehouses, 2 rail cars in logistics centers, and 1 ship at seaports. And what we had seen as a result was we had seen over the road, just like road transportation out of this instances was about 80%. And this is seen in real life as well. If like intermodal transportation is not forced, everything will be sent over the road. What we had seen was in terms of the demand level, when we used intermodal transportation, first of all, the observation was like in the low and medium demand case, with this number of beneficiaries, when we had less than 50,000 low demand and medium demand ones, we don't see intermodal transportation. But when demands are high, like the Maraş earthquake or the expected Istanbul earthquake, then we are seeing in the past instances, like on average about like 15% use of intermodal transportation. This is a large percentage, just to satisfy in the first 72 hours, 3 days period. And what we are seeing as like the demand met period and objective function values go like that. For high demand instances, we are seeing a later satisfaction of full demands. For small demands with this available capacity, for example, low and medium, we are able to satisfy all of the needs in the first day. But like when we have larger demand instances, we cannot reach. And after analyzing this 305 demand instances for the century of data, we had observed container warehouse usage frequency. The results of this study can be used for infrastructure investments. So this is again drawn to scale.
And these are the container warehouse locations. And what we are seeing is, like, for example, Tekirdağ is not used that much. Kocaeli, Kastamonu, and these are the usage frequencies, like 22% use is like large ones are used more. Then we calculated logistics center usage frequency as well for future. These are not all active right now, but in the future, if an investment is going to be made, it should be made to these large ones. If intermodal transportation is favored, we have to use and satisfy the requirements for these logistics centers at the beginning. And I also looked into capacity load share. This is like demand and supply instances combination. So origin destination pairs, which are used most frequently. Okay, so what we are seeing is like these ones are used more frequently. So if we are going to make infrastructure investments, both over the road and railroad, we have to invest into these origin destination pairs. If there are problems, we have to fix them. And I also did tested the possible Istanbul earthquake, and this was like an observation. So with Istanbul earthquake, it's a large earthquake, expected earthquake. It's not possible to ship all containers within the 72 hours without using intermodal transportation. So when I didn't let intermodal transportation just use current approach, we aren't able to satisfy all the needs just using single mode transportation. And we also did some sensitivity analysis, again, with different levels of demand and intermodal transportation rate. And we also thought about disruptions on the over the road transportation, like when the roads are damaged, when we cannot use over the road, and it ends up with some delay. As expected, when there are delays in over the road transportation, intermodal transportation is used a lot. And when there are delays, the satisfaction is prolonged, full satisfaction of the needs. And we also did a test sensitivity analysis using intermodal transportation, unimodal transportation, and over the road transportation. Unimodal is like once it starts with rail, it should end with rail. And over the road is just using road transportation. And what we are seeing is like in high demands cases, it's more beneficial to use intermodal transportation. And this was also published in International Journal of Disaster Risk Reduction recently. And one thing I want to highlight before I end and take your questions is like, as a result of this research, while conducting this research, we found that some of the warehouses are just very near to the railroads. If the over-the-road capacity, if trucks are not available in these container warehouses, what we had seen was this. So here is the location of the container warehouse, and this is where the railroad passes. So if Turkish State Railways, TCRD, makes this investment, just connects this 200 meters to the warehouse, it can ship immediately these containers using railroad transportation, and they can reach to the disaster area if railroad is not damaged. And we had seen Muş is another example. It's just 100 meters. This is where railroad is. This is where the container warehouse is. This investment has to be done. So in order to reach to beneficiaries in the long run, to use intermodal transportation. Samsun, again, like 100 meters from the railroad to the container warehouse. So thanks for listening. I hope you enjoyed the presentation, but if you have any questions, the stage is yours. So if you have any questions, I can say.
Thank you very much, Alp Hocam. So any questions from the audience? If you have a question, you can write in chat box or you can raise your hands. wait. So maybe while we are waiting, I can have a question. I have a question, so maybe I can ask my question.
Okay.
So this is intermodal transportation. So
Yes.
is it also possible to use this intermodal transportation recursively? I mean, from one node to another node and from one to another one recursively.
Yes, you can do that actually. Our model allowed like moving from shipping from, let's say, Manisa to Denizli, then Denizli to Manisa, because like, so we took cycles, but what you are saying is like, go from Manisa to Balıkesir, then to Kocaeli, then to Bolu. Are you asking that?
I mean,
Recursively meaning that.
you can have some hubs, so there could be some hubs, so those hubs could be somehow saving the warehouses maybe in large amounts. So from one hub to another hub, you can use intermodal transportation. And from one hub to another hub, you can use another means of intermodal transportation. So that's what I mean, recursive from one hub to another.
Yes, yes, you can use different modes as well. So, for example, for the Istanbul earthquake, so what is recommended here, for example, roads, but in order to reach to this location, you have to go over the road. So the rail, sorry, for example, in order to reach from, let's say, Muş warehouse to Diyarbakır, yes, you can go on the road. And then from Diyarbakır to Istanbul, you can go on the rail. So it will act as a hub. What we did, our formulation allows multiple transfers between modes, but we did only one transfer. So not multiple transfers, because like each transfer, load transfer brings an intermodal exchange parameter, which is represented in the objective function model. Objective function over here, it is penalized by W, because one caveat of intermodal transportation is time duration in periods spent transferring one container from one transportation mode to another node. So it's called dwell time, waiting time. So if you transfer too many times, then the benefits of intermodal transportation is not visible. So we have to just transfer once and reach to the destination as quick as possible. So what we allowed was like source, container warehouse, intermodal hub, and then the distance. So we allowed transfer for change of modes once in our model.
In one of the slides, you have shown speed of the vehicles and usage of the intermodal transportation.
Yes.
What was the aim of giving the speed and size of the trucks?
What we wanted to make it as much realistic as possible, and this is the average speed for trucks. What we did was like we converted trip durations using basic time distance speed formula. So we used this time in our time periods. So using this one and taking the distance from General Directorate for Highways. So we took the distances and then we used these speeds and then used this time, trip durations, time for, let's say what time was defined as. So travel time in periods from node I to node K via mode N, transportation mode N. So from each node, we have origin destination pairs between each node. So we use that speed, and capacities are used to like select which transportation mode can be used. So capacities are like a vehicle of mode N, how many number of containers they can hold. So if you use rail, for example, it's more advantageous. It can hold 24 items, 24 containers, each rail car. And like ships, you can use 200 containers at a time.
Like we had examples in the beginning like this. So if you use ships, you can, there's ample capacity, but of course it is slower. So that slowness is represented in the formulations using the speed of the ship.
So, I mean, how do they reflect your results? I mean, in the table, I can see some table. So in the table, how they affect the results?
These ones,
Yeah.
they are reflected, for example, they are reflected, the capacity and the speed is working together. For example, in the Istanbul earthquake, you can see it more. So it's not possible to ship all containers within the first 72 hours. In order to ship, you have to use sea mode because like the capacity is large. For example, from Samsung warehouse, you have to send those 200 containers to Istanbul via sea. Otherwise, there's not enough capacity to ship all of the items from Samsung to Istanbul within the first urgent period. So that capacity worked together with the speed, and we had seen rail mode also used extensively for the Istanbul earthquake as well.
Yeah, I mean, what happens if there's some vacuums in demand or in the size of the containers? So are they all fixed or is there any kind of vacuums?
Stochasticity, you mean like randomness?
Yeah, not random, maybe somehow fuzziness or some maybe.
No, we didn't consider that. Like we took just like 5 trucks. We didn't test these ones. So we didn't give like 10 trucks. If truck availability is more, what happens? If rail availability, if like more rail cars are available, we didn't test that actually. So that might be a future work that other experimental studies might be done on that. So there's no fuzziness in that. So we are giving 5 trucks in cities to hosting container warehouses. So they can immediately ship 5 containers at least to the disaster area. And mostly what we had given was enough for low and medium demand instances. So most of the time, let's say low and medium demand instances are like majority of the demand instances. So about like 90% of the time, actually what we had given was enough. So out of assume that the high demand is like 30, so 300 instances, about 90% of the time, what we had given was enough to satisfy the urgent period. But when demand becomes high, demand level becomes high, like the Maraş earthquake, we have to use in those instances intermodal transportation. So the benefits are more visible when we have high demand levels. So,
Any more questions? So we have still time.
so we have like all of these are newspapers, like news that happened. So the items for future reference, like we can, because all of the relief items I bet are depleted right now in the container warehouses. So what we can do is like we can move on and at least satisfy and set the stage for intermodal transportation, both in terms of investments in the like closer ones, just to use railroad transportation, make this investment. So as what should I do next is like invest into these ones, like AFAD and Turkish State Railways should coordinate and then make this, these are small investments for what had been invested already. I'm saying like it's about $100 million were invested at the time for this container warehouse. This is nothing for what Turkish State Railways and AFAD. They just need to coordinate. And as well, this doesn't require, the first study doesn't require any other investment. I'm just reshuffling the inventory here. So at least some of the warehouses has to be converted to equivalent warehouse and kept readily available, fully that can satisfy the needs of the beneficiaries fully. And I believe
this is your recommendation, but this is not in real life. It's not applied yet.
Yes, not yet. I have shared the results with AFAD, but like it was very recently, so I believe they didn't have time to implement this. But now we don't have any inventory, so the stage is open for like new investments, and now the container warehouses can be organized like this. And if we have this, even just these 3 warehouses, they would be enough for most of our earthquakes. Just the bigger ones, we will have problems again, but like intermodal transportation will cover that. So these are, like, as I said, must be converted, but if required, the ones with the star can be also converted to equivalent warehouses. Okay, any other questions?
I think there is no more, Alp Hocam. So we again thank you.
Okay, you are more than welcome. Thanks for the invitation.